Okay, semua boleh dengar?
Boleh, Miss.
Okay, so kita start dengan exercise Okay, so exercise we won't be discussing all lah sebab banyak kan. So kamu mau discuss which questions? Ada berapa ni? Okay, so pilihlah mau soalan mana satu.
Number 1 boleh ke, Miss?
Exercise 1, number 1.
Iya.
Okay, exercise 1, number 1. Mana tu? Ini. Okay, so exercise 1, number 1. So the situation is a straight conductor. So dia bagi kita straight conductor with the length of 20 centimeter. So it moves in a uniform magnetic field of flux density 20 millitesla. And then dia bagi kita the speed which is 10 meter per second. So the velocity makes an angle of 30 degree to the field. Okay, so sekarang velocity to the field is 30 degree, but the conductor is perpendicular to the field. So we have to determine the induced EMF. Okay, so given is the length, which is 20 centimeter, and then magnetic flux is 20 millitesla. Okay, and then the velocity pula 10 meter per second. Okay, so the situation kalau kita lukis, so this is the straight conductor. Okay, and then they mention they are perpendicular to the magnetic field. So assuming this is our magnetic field. Okay, so that is our magnetic field. Okay, lepas tu they mention they move 30 degree to the field. So the velocity is something like this lah. Yeah. So the 30 degree to the magnetic field. Okay. So sekarang induced EMF untuk straight conductor kita guna LVB sin theta. So theta ni it is the angle between the velocity and the magnetic flux density. So angle there is 30 degree lah. So we don't have to calculate the theta, we just directly use sin 30 degree. So the induced EMF kita akan dapat 0.02 volt. Okay, boleh?
Boleh, Miss. Dapat.
Boleh, Miss.
Dapatkan. Okay. Lagi soalan lain? Exercise okay sudah? Jadi sudah soalan lain?
Miss, yang 2 Roman 2 tuh orientation tuh apa maksud dia tuh?
Orientation tuh maksudnya dia punya direction lah kiranya. Kejap, mana satu tuh soalan exercise?
1 juga.
One, number. Okay, so cara kamu jawab yang ini, what is the orientation? Kamu boleh lukis ataupun tulis dah lah. Kalau Miss tulis di Roman 2. Okay. So, Miss akan tulis the induced EMF will be maximum. Miss tulis dulu lah. When the angle between vector area and B is at 90 degree. Okay. So, maksudnya NBA omega sin theta ni sin 90 degree should equal to 1. 1 untuk dapat maximum induced EMF. Okay? So, kamu boleh tulis ataupun lukis lah orientation dia. So, orientation dia basically dia punya vector A ni. So, this is our area, the normal to the conductor. There should be 90 degree dengan dia punya magnetic field. So, magnetic field tu kalau kita lukis, ni bukan 90 degree. Lupa. So, kalau kamu lukis, this is our B, this is our area. So, it should be 90 degree lah. This is the orientation. Sebab dia tanya orientation kan? Yeah. Orientation of the coil with respect to the magnetic field. Boleh faham kah?
Oke, Miss, boleh. Thank
So,
you.
mau cakap dia parallel, Miss.
Apa?
Mau cakap dia parallel lah tuh, Miss.
Yeah, so the coil should be parallel to the magnetic field lah. Ataupun kamu boleh aja cakap pasal the angle of this vector area ni mesti 90 degree with the magnetic field.
Oke.
Okay. Ada soalan lain? Lagi yang lain?
Tiga B, Miss.
3B. Exercise berapa tuh? Exercise 2?
Iya.
Okay. 3B. 3B Roman 1 and 2 lah.
Iya, Miss.
Okay. So, soalan 3. Dia cakap, at the instant when the current in an inductor is increasing at the rate of 0.064 ampere per second, the magnitude of the back EMF is 0.016 volt. So, if the inductor is a solenoid with 400 turns and the flows in it is 0.72 ampere, we have to determine the magnetic flux through each turn and the energy stored in the solenoid. Okay, so sekarang given is the rate of current, which is 0.064 ampere per second. Then back EMF to just EMF lah, 0.016 volt. Okay, so dia untuk soalan B, dia bagi number of turns which is 400 and then the current is 0.72 ampere. Okay, so ini dia suruh cari magnetic flux. Magnetic flux kan? Yeah. Okay, so magnetic flux is V lah, dia suruh cari. So, untuk kita cari ni, we have to use the induced EMF punya equation, which is E equal to L di over dt. Okay, then ingat L, which is inductance, self-inductance, is also equal to NV over I. Okay, so the relationship is L untuk cari magnetic flux lah. Okay, so after dapat tu, substitute the value, this equation dulu. So we have di over dt. Okay, so rearrange untuk dapat magnetic flux, we will get I over N divide by di over dt. Okay, so kamu akan dapat V P to be equal to 4.5 times 10 negative 4 Weber. Okay? Difaham? Boleh kah yang ni?
Boleh,
Boleh.
Miss.
Okay, ha? And then question Roman 2, they just suruh cari energy stored. Energy stored is half Li square lah. So kamu ada L. Do you have L? L tu kamu kira
Dari
aja
3E.
lah kan. So ini N V over I square. Kamu ada tiga. Oh, okay. L dari question A. Okay. So kamu dapat, dapat tulis balik. 0.25, I is 0.72. So dapat 0.0648 joule. Okay, so that is energy stored lah. Okay?
Oke, Miss.
Okay. Lagi soalan lain?
Soalan 4 lagi, Miss.
Okay, soalan 4. Okay, soalan 4. So now a current of 1.5 ampere flows in an A core solenoid of 1 centimeter. 1.5 ampere. So this is a solenoid and then 1 centimeter radius and then 100 turns per centimeter. So we have to calculate the self-inductance per unit length and then the energy stored per unit length juga. Okay, semua ni over L lah. Okay, so given is the current 1.5 ampere. Then we have the radius 1 centimeter. Then you also have N. N is number of turns per length. So this is 100 centimeter per 100 turns per centimeter. Okay, so itu information that we have. So question A, we have to calculate the self-inductance per unit length, which is L over small l. Okay, so ini kita akan dapat dari the equation for solenoid, which is mu naught N square A over L. Ini kamu tahu kan dapat dari mana?
Ya, Miss.
Ada di page, okay, this one. Kita dapat dari page 11, soalan yang ini. Okay, soalan notes. Okay, so dapat yang ini kita perlu darab dengan 1 over L. So why do we need to multiply it with 1 over L? Because we need self-inductance per unit length. Okay, so kita perlu ada 2. So we darab dengan 1 over L. So we have mu naught N square A over L square. Okay? So bila kamu tengok dari sini, we can actually combine this N over L. Sebab both ada square. So N over L square A. Okay? Dapat yang ni. Before that, actually, bagus kamu tulis area ni, kamu calculate dulu berapa value dia. So you should get pi centimeter square. Okay, so why do we need to stick with centimeter is because dia punya number of turns per length is given is in centimeter. So sekarang bila ni dalam centimeter, kita continue juga lah, radius should be in centimeter as well. Jangan convert this into meter and then you use this in centimeter. Salah lah jawapan kamu, okay? So if the number of turns per length is in centimeter, your radius or your area needs to be in centimeter. Okay?
Miss, kalau tukar yang number of turns per length to pergi meter per meter?
Boleh jual lah tapi macam mana macam sedang buat salah lah kalau kamu convert this into meter, per meter. Because dia bukan directly meter kan, dia per meter. Tapi boleh aja lah kalau dapat jawaban betul, maksudnya betul lah tuh.
Ya, dapat
Oke.
juga, Miss.
Oke, ngam lah tuh kalau begitu. Oke, untuk siapa yang tidak mau convert, confused on how to convert kalau dia per meter, kamu stick to centimeter lah. Okay, so area should be in centimeter sebab N over L is in centimeter. Okay, so sekarang, before that, ini untuk assignment lah. Make sure kamu ada kira area begini ya, sebab dapat markah nih. This is J1 I think. Okay, so if in assignment ada minta calculation of area, tulis macam ni supaya dapat markah. Kalau tidak tulis, tidak markah. Okay. Lepas tu, dapat yang ini, just substitute lah the value. So this is 4 pi 10 negative 7. And then this is 100 square area is pi. Okay. So kamu akan dapat inductance per unit length 0.039 Henry per meter. Okay.
Oke, Miss.
Oke ya. Tidak masalah kan? Boleh faham?
Boleh.
Setakat
Boleh,
yang bahagian
Miss.
oke kan? Tidak confusion kan? Oke. Continue question B. We have to calculate the energy stored per unit length juga. So energy stored for solenoids Li square sama juga lah. So we have to, before that kita have, so inductance is N square A over Li square. So we have to multiply this whole thing with 1 over L. Sebab kita mau U over L. Okay, so dari sini kita akan dapat half. So basically dapat benda yang dari di atas tadi lah. Square A I square. Okay, so yang ini we can write it down as inductance per unit length lah. Okay, so we will get U over L half inductance per unit length I square. Okay, so you will get half 0.039 1.5 square equal to 0.0439 joule per meter. Okay?
Oke, Miss, dapat.
Ya. Okay, soalan lain? Ada soalan lain? Exercise 3, exercise 2. Exercise 2 semua okay? Ini semua okay? Jika ada soalan lain?
Oke, Miss.
Lagi
Oke.
yang lain? Mana tahu ada yang lain mau tanya tapi dorang malu.
Tanya ketika kamu nanti dia marah sama itu.
Di sini sudah kodenya. Oke, cepat soalan lain. Tidak? Oke, exercise 3. Before we continue to quiz, exercise 3, okay?
Oke.
Okay. Eva aja nih yang okay.
Oke, Mbak Miss.
Kaya tada,
Okay,
kaya kita
Miss.
continue. Quiz lah, quiz. Okay.
Oke, Miss.
Discussion. Okay, quiz. Oh, quiz kita discuss semua pula, lupa. Okay, quiz. So, question, objektif kalau kamu baca job. I mean, objektif kamu tengok answer scheme je lah nanti. So, subjective, question 1. Okay, so question 1 for subjective. So given is a square loop of wire, so each with sides 5 centimeter. Okay, so they are in a uniform magnetic field of 0.16 Tesla. So what is the magnetic flux in the loop when B is perpendicular to the face of the loop, and then when B is at an angle 30 degree to the area of the loop? Okay, so first question A. So the magnetic field is perpendicular to the face of the loop. Okay, so sekarang ni perpendicular. So this is area, this is magnetic field. Okay, so magnetic flux is BA cos theta. Okay, so the theta is the angle between A and B lah. Okay, so the A vector A ni is always normal to the surface lah. Okay, so B is 0.16, A is 0.05, 0.05, dapat 2.5, then negative 3 meter square. Okay, so 2.5 times 10 negative 3 cos, so the angle between area and magnetic field is 0 degree. So cos 0 degree lah. So magnetic flux at this point is 4 times 10 negative 4 Weber. Okay. Lepas tu dia cakap bila the magnetic field is 30 degree to the area of the loop. So this is your loop of wire. So your area is this one. So if you were to draw the magnetic field, okay, so this is your magnetic field. So they mentioned the magnetic field is 30 degree to the area of the loop. So the angle is just 30 degree lah. Okay. So we dapat magnetic flux BA cos theta. So this is 0.16, 2.5, then negative 3 cos 30 degree. Okay, so kung dapat magnetic flux at this point is 3.46 times 10 negative 4 Weber. Okay, that is question 1A and B. And then question C, disuruh kita cari what is the magnitude of the average current in the loop if it has a resistance of So the resistance is 0.012 ohm, and it is rotated from position B to position A. So this is question B lah. In 0.14 seconds. Okay, so sekarang ni kita perlu cari di current. Okay, so untuk soalan ni, we should use E equal to IR because we are looking for the current. Okay, but before we can find the current, we have to find the EMF lah. Okay, so EMF is calculated using the equation. Okay, so this one is gonna be phi at B minus phi A over the time distance. Okay, so this is negative 3.46 times 10 negative 4 minus with 4 times 10 negative 4 over 0.14. So you will get EMF to be equal to 3.86 times 10 negative 4. Let's zoom in. Yeah, 3.86 times 10 negative 4 volt. Okay, so dari sini baru kita guna I equal to EMF divided by the resistance. So you will get the current to be equal to 32.14 milliampere. Okay? So
Okay,
that
Miss.
is question 1A, B, and C. Okay? And then question 2. Question 1, okay? Ano soalan?
Okay.
Okay. Question 2. So question 2A, for your syllabus, there is no derivation. So actually dalam PSPM pun dia akan tanya derivation lah. Okay, so question 2A, Miss tidak akan explain. That is in your lecture notes lah. So we will go into 2B lah. Okay, so we have to calculate the value of L if the number of turns is 100 and then the length is 5 centimeter with the area 0.3 centimeter square. Okay, so it is a solenoid lah. Okay, so untuk soalan ni, you will just use the equation for solenoid lah, which is mu naught n square A over L. Okay. So this one, 0.3 times 10 negative 4 meters square. Okay, this one is 0.05 meter. Okay, so substitute all that values and then you should get 7.54 times 10 negative 6 Henry. Okay? Okay. So that is on our exercise and quiz lah. Itu je. Ada apa-apa soalan?
No,
Okay,
Miss.
habis sudah. Habis sudah, tidak ada soalan. Assignment ada soalan?
Tiada, Miss.
Tidak, assignment siap sudah?
Sedikit lagi.
Belum lagi.
Miss,
Satu soalan lagi.
Satu soalan lagi, okay, boleh tuh.
Miss assignment mau tulis guna tangan atau boleh type juga?
Boleh type boleh kah? Type macam tu boleh.
Miss.
Oke.
Boleh, tapi boleh tulis di iPad lah kalau kamu mau tulis di iPad. Oke, siapa lagi ada soalan? Kalau tidak soalan, habis lah kelas kita hari ini.
Yeay.
Habis sudah kelas kita this week. Ya, this week habis kelas. Oke, off recording.